Nice to meet you. I'm Khatar Choktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain carboxylic acid for O-level and IGCSE chemistry students. Let's get started. In this topic, we are going to talk about the reaction of carboxylic acid with metal, with bases, with metal, with bases, with carbonates, including name, formulae of the salts, and so on. Then the main topic is ethanoic acid, how the ethanoic acid is prepared from ethanol. Next thing is, what are the basic carboxylic acid reactions? Describe the reaction of carboxylic acid with alcohol in the presence of a catalyst to make esters. So these are the basic main important point of this topic, this chapter. However, we will discuss the nomenclature of carboxylic acid, general structure and formulae of the 4-carboxylic acid. Let's talk about it. What is the carboxylic acid first of all? A compound that is having oxygen, double bond carbon, single bond oxygen and single bond hydrogen. Any organic compound, if it is having this functional group, it is said to be carboxylic acid. Any organic compound that is having O, double bond C, single bond O, H group, this whole group is known as carboxylic group. So any organic compound, if it is having this carboxylic group, if it is hosting this carboxylic group, it is known as carboxylic acid. It will be the member of carboxylic acid homologous series. For example, if there is only one carbon in carboxylic acid, then its structure, its displayed formula will be like that. C, double bond O, single bond O, OH, and one hydrogen with this carbon. One carbon acid is named as methanoic acid, methanoic acid. One carbon compound's name starts from meth. And ane mean is alkane. OIC acid, that is basically the name of functional group that is written for carboxylic acid. So its name is, one carbon acid's name is methanoic acid and its molecular formula is C1H2O2. Now come towards the second member of this homologous series. If the carboxylic acid is having 2 carbon atom, then its structure formula or its displayed formula will be like that. Now, as you know, it is having 2 carbon atoms, so its name will start from eth. Eth mean 2 carbons, carbon single bond, ane, and for this functional group, we will write OIC acid, ethanoic acid. And its molecular formula will be C2H4O2. If carboxylic acid is having 3 carbon atom, the next member of this homologous series, this is the structure formula of 3 carbon homologous series carboxylic acid. And its name will start from probe. Probe means 3 carbons. All carbons are single bond. So I'm going to write ane without E. Now I'm going to add OIC acid for carboxylic acid. So its name is propanoic acid. And its formula is C3H6O2. From these molecular formulas, I can make, or you can make, we can make a general formula. You can see that there is a ratio of 1:2 ratio. There is 1:2 ratio of carbon and hydrogen, and oxygen is same in all these formulae, in all these members and so on. So the ratio of the carbon and hydrogen is equal to 1:2. Same, 2:4, again 1:2. 3:6, again 1:2. So I can make the general formula, I can write the general formula for a carboxylic acid that is having one acidic group, that is having one this acidic group, then its general formula will be CnH2nO2. This is the general formula of carboxylic acid. Any carboxylic acid that is having only one COOH group, I mean one carboxylic group. If any carboxylic acid that is having one carboxylic group, its general formula will be CnH2nO2. Now the next one, if the carboxylic acid is having 4 carbon atoms, so 1, 2, 3, 4, straight away 4 carbon atom, for example, then it's one of the possible displayed formula will be like that. And I mean, what is its name? 4 carbons are lying in the longest chain. All carbons are lying in the same longest chain. So its name is bute. The longest chain is having 4 carbon atom. So its name is bute. 4 carbon names start from bute. In mean all carbons are single bond. Then OIC acid. As you may have seen in my previous lecture of nomenclature, that first of all, we write the name of branch. If there is no branch, then we will write the name of longest chain, eth, prop, bute, pent, and so on. Then we write the suffix in or in. Then finally, we write the name of the shortcut name of functional group. So its name is butanoic acid and its formula is C4H8O2. Here is another isomer of this carboxylic acid that is also having total 4 carbon atom, but its longest chain is having only 3 carbon atom. In this case, I'm going to place 1 carbon over here, one CH3 group over here, and there is another CH3 group. Here is H, O, and H. So in this case, this carboxylic acid is having 2 methyl group. Overall, what is the name? Name will be with respect to its longest chain. This is the branch, and branch is lying at carbon number 2, as this carbon is always carbon number 1. So numbering will start from this carbon. This is carbon number 1, this is carbon number 2, and this carbon is carbon number 3. The branch is methyl. 1 carbon branch name is methyl, and it's starting, from 1 carbon atom. So its name is methyl. Its position is 2. So I'm going to write the name. First of all, the position of branch, 2, then dash, hyphen, then the name of branch, methyl, 2, methyl, then the name of longest chain. 3 carbons are over here. So I will write prop, and in for all carbon-carbon single bonds are over here, and I'm going to add OIC acid. So this name is, its name is 2-methyl propanoic acid. Again, its formula is also similar, C4H8O2. These both structures are having different name. One is said to be butanoic acid, and other one is said to be 2-methyl propanoic acid. But they are having same molecular formula. So these compounds are said to be isomers of each other. Isomers of each other. So they are isomers. Compounds having same molecular formula, but if they are having different nomenclature, if they are having different names, as they are having different structures, so they are said to be isomers. So you will have to remember these names, this nomenclature, structure formula, molecular formula, till 4-carbon carboxylic acid. Now come towards the next section, the next point, that is the chemical properties of carboxylic acid. Carboxylic acid, like all other acids, for example, I'm starting from CH3 ethanoic acid, that is a vinegar. Ethanoic acid like all other acids, it can react with metal like magnesium, like sodium, like calcium, like iron, zinc, lead, and that's all. I mean, any metal that is more reactive than copper, any metal that is more active than copper can react with organic acid. This is basically an organic acid. Other acids are said to be inorganic acid like H2SO4, HNO3, HCl, H3PO4. These are said to be mineral acids or inorganic acid. And this acid is said to be organic acid. So any metal that is more active than copper in the reactivity series can react with carboxylic acid and they will make hydrogen gas. And next thing is salt. Every time a salt is formed. For example, I'm going to write once again this ethanoic acid, and it is supposed to react with sodium. Obviously, this will be very vigorous reaction because sodium is the highly reactive element or highly reactive metal. So what is being formed? There is the cleavage of this OH bond. OH bond is broken down, and I'm going to write the organic portion over here except hydrogen, this one hydrogen. Only this hydrogen is broken down. I mean, OH bond cleavage occur over here. Rest of all hydrogens will intact with the carbon. OH bond is broken down. OH bond is broken down in this case. So it's having one negative charge after loss of hydrogen. And here is sodium that is having one positive charge, plus there will be hydrogen, H2. Hydrogen gas is formed, and we can write half mole of H2. Yes, it is true. What is the name of this salt? This salt name is very much pretty similar as that of the name of an ester. First of all, I'm going to write the name of this one component, that is a metallic ion. I'm going to write sodium. Sodium. So the first name will be the name of metal. Then, how many carbons are there in this portion? 2 carbons are lying over here. 2 carbon names start from eth, carbon-carbon single bond, ene, and then we add O, A, T, E. Sodium ethanoate. This is the style of nomenclature of esters. Esters names are basically written like that. So its name is sodium ethanoate. Sodium ethanoate. This is the name of the salt form, and hydrogen gas is formed. So whenever any metal that is more active than hydrogen, that is more active than copper, when it is allowed to react with the carboxylic acid, they will make 2 compounds. 2 products are over here. One is the hydrogen gas, and the next thing is a salt. For example, I'm going to react the same ethanoic acid. I'm going to react ethanoic acid with magnesium. Then how to make the formula of salt and how to write the balanced chemical equation. Magnesium solid, and it goes to with this acid. Again, there is the breakage of OH bond, and I'm going to have this one negative ion. This is the magnesium metal and it belongs to group number 2. So its charge will be equal to +2. I mean, this charge will be 2 plus over here. So this charge is equal to 1 minus and its charge is 2 plus we will make hydrogen gas. What is the formula of the salt? Positive and negative will be cancelled out. 2 will be over here and 1 will be over here. As you have seen that there is the group of different elements, non-metallic elements. So I'm going to write Ca3COO bracket twice Mg1. There is no need to write 1. So this is a way to make the formula of any ionic compound. As it's an ionic compound, it's a salt, and plus we will make hydrogen. This time to balance this chemical equation, as we are using the 2 moles of this carboxylic acid. So we will write 2 over here, 1 magnesium, 1 over here, and 2 hydrogen, I mean H2 will be formed. Yes, 2 hydrogen will be formed. 1 into 2. 2 hydrogens will change into H2. Rest of these 2 portions are lying over here, and 1 magnesium, 1 magnesium. What is the name of this salt? Again, first write the name of this portion, this metal. Metal is magnesium. So magnesium ethanoate. Ethanoate. Simple normal name is magnesium ethanoate, and this is the hydrogen gas. So this reaction, this type of reaction is pretty similar for all type of carboxylic acid. Any carboxylic acid, if it is allowed to react with any metal that is more active than copper, that is more active than hydrogen, then they are supposed to make 2 things. Number 1, hydrogen. Number 2, salt, and so on. Same is the case, reaction of acid with a base. For example, again, I'm taking ethanoic acid and I'm going to react it with sodium hydroxide. What are the bases? Bases are metal hydroxide, bases are metal oxide, bases is ammonia in your syllabus, and so on. So what will be the answer, or what will be the products? Number 1, once again, there is a cleavage of this OH bond. I mean, this H is lost by this carboxylic acid. And here, OH negative ion is going to take part in chemical reaction. So this one hydrogen and OH group will meet together to make H2O. 2 hydrogens, 1 oxygen will make water, plus again salt is formed. And almost the method is quite similar. C double bond O, N, A. So this is sodium ethanoate and water is formed and equation is balanced. So this is called acid alkali or acid base. Acid alkali neutralization, or it is also said to be acid base neutralization reaction, to give water and salt is formed. Next thing, for example, we can react ethanoic acid with sodium oxide, Na2O. It's also a base. Once again, when acid react with the base, when any acid is allowed to react with the base, they will make salt and water, NH2O, water. So what is the salt in this case? As you know, water is the same, H2O plus. Again, this bond is broken down, metal is taken from here, negative portion is taken from this portion, and we are going to make salt, CH3, C double bond O, O, N, A. To balance this equation, as you have seen that there is 2 sodium atom, so I will multiply 2 over here with this salt, so I have to multiply 2 with this compound, and H2O is formed. Yes, it is 2, and 2 mole of salt, and name of salt is sodium ethanoate. Sodium, E for 2 carbon, N for single bond, OATE is the ending name of ester. As I told you, the name of salt is written like the name of an ester. So when this carboxylic acid is allowed to react with base, with alkali, they are supposed to make salt and water. When acid is allowed to react with the metal, it is supposed to make salt and hydrogen gas. The next thing, if this acid, like organic acid, carboxylic acid, is allowed to react with any metal carbonate. For example, this time I'm going to use MgCO3, metal carbonate. Then 3 products are formed. Number 1, water is formed. Number 2, carbon dioxide gas is formed. Number 3, salt is formed. So 2 products are fixed. I mean, they are definitely formed whatsoever is the nature of this carboxylic acid and whatsoever the nature of this carbonate. Water is formed, carbon dioxide is formed, and salt is formed. So once again, let me make the formula of salt. What will be the formula? There is the cleavage of OH bond, and this is the negative portion. This is the positive portion that has been changed into water. And let's see over here, what is the salt? CH3COO1 negative, and here is the magnesium. It belongs to group number 2. A positive and negative will be cancelled out. 2 over here, 1 over here. Again, its formula will be CH3COO twice Mg, magnesium ethanoate. Now hydrogen from here basically, and I'm going to balance it by adding 2 over here. So 2 hydrogen from here, 1 oxygen from here, they will make water. 2 hydrogens and 1 oxygen from here, they will make water. And CO2, the rest of the portion from here, CO3 carbocation, CO3 that is called carbonate ion. From CO3, that is the remaining portion will be in form of CO2. So 1 oxygen of water and CO2 is formed from CO3. Magnesium react with this negative portion of the acidic compartment or acidic species, and it makes salt, and its name is magnesium ethanoate. So whenever any carboxylic acid is allowed to react with any metal carbonate, they will make 3 species. They will make 3 basic compound: water, CO2, and salt. Every time, definitely, if you are going to change the nature of carbonate or nature of acid, then the salt formula of salt will be different. But if you are using, whatsoever you are using the acid or carbonate, every time H2O and CO2 will be the same. Their formula, obviously, their name will be same, and these are the two essential product of overall 3 products. So salt is formed. Every time you will have to make the formula of salt, you will have to check the formula of salt, and H2O and CO2, carbon dioxide gas, is formed. So these are the basic typical chemical properties of carboxylic acid, as the other acids are doing the same thing. But there is a unique property of carboxylic acid. There is unique property of the carboxylic acid that is not shown by the other acid. I mean, this property cannot be shown by sulfuric acid, by HCl, by HNO3, by H3PO4. What is that property? That property is basically that is said to be reaction with alcohol. So reaction with alcohol. I mean, this time acid plus alcohol. If you are using simple acid like HCl, like HNO3, like H2SO4 plus alcohol, no any product is formed. No appreciable organic product is formed. No major product is formed. But if you are going to use any carboxylic acid, again I'm using this vinegar, ethanoic acid, with alcohol. For example, I'm using methanol, 1 carbon alcohol goes 2. The conditions are, we are using concentrated H2SO4 plus we are going to heat the reaction mixture. So this time, this is a unique reaction. This is the different behavior of the carboxylic acid. This time, it's not going to lose H. This time, it's not going to lose H. It's going to lose OH group. So this time, this acid is not behaving as an acid. Even though it's an acid, it's the member of homologous series of a carboxylic acid, but it's not going to behave as an acid. It's going to behave as simple reagent, which is losing OH group. In this case, alcohol, it will contribute hydrogen. So H from alcohol, OH from acid, they will meet together to make H2O. Plus, these group will attach or will be combined to make another compound that is called ester. So what is the, formula of this ester? CH3, C double bond O. Now there is a portion of alcohol O, CH3. There is the, if I'm going to cut this molecule into two portions, and this is the part from alcohol, this is part from alcohol, and this portion is from acid. This portion came from acid. So what is the name of this compound that is known as ester? Generally, it is said to be an ester. Its name is, for the nomenclature, for the sake of nomenclature, I'm going to cut this molecule over here. Only one carbon is lying over here, so its name will start from methyl. It is said to be a branch. This portion that is having no oxygen is said to be a branch. As I have cut this molecule into two portions, one portion is having no oxygen, other portion is having all oxygens, both oxygens. The portion that is having no oxygen, its name is written first, that is called methyl. Now I'm going to write the name of this portion that is having two carbon atom. Two carbon alkanes are, compound will start from eth. Two carbon compound name start from eth, and carbon-carbon single bond, so I'm right in, and after removing E, I'm going to add O, A, T, E. So its name is methyl ethanoate. It's the name of this compound that is called ester. So whenever the carboxylic acid are allowed to react with any alcohol, in the presence of H2SO4, concentrated H2SO4, and in the presence of heat, two compounds are formed. One is called inorganic compound, that is water, H2O, and other is said to be organic compound. This is called an ester. And here is the name of the ester. Here is the method to give the name an ester. The next thing is, this reaction is specifically generally known as condensation reaction. It's called condensation reaction. Condensation reaction. So this is the typical and unique property of organic acid, carboxylic acid. Next thing is the preparation of carboxylic acid. Preparation of carboxylic acid. First of all, for example, I'm supposed to make methanoic acid. This is the formula of methanoic acid. As you know, this acid is having one carbon atom. So it will be made from one carbon alcohol. This is one carbon alcohol. One carbon alcohol, methanol. And it is oxidized basically. It reacts with oxygen, especially nascent oxygen, you can say, in the presence of KMnO4, that is acidified, in the presence of H positive ion aqueous, and heat under reflux. Heat under reflux. So basically, one carbon alcohol going to oxidize, and it is changing itself into carboxylic acid. What is oxidation? Oxidation is the removal of hydrogen and introduction of oxygen. So overall, generally, two hydrogens are removed and one oxygen is introduced, and this new compound form is called acid. And its name is methanoic acid, methanoic acid, as I have told you. So its name was methanol, meth one carbon, in for alcohol, methanol. So the oxidation of methanol will give methanoic acid. For the complete balanced chemical equation, I'm going to put 2 over here plus H2O. These hydrogen, these any two hydrogen from these three hydrogens will change into H2O. H2O, water will be formed. Water is formed and acid is formed, and these oxygen are called atomic oxygen or nascent oxygen, and these oxygen are given by the KMnO4, any oxidizing agent. This is oxidizing agent, KMnO4. The conditions are acidic, we add acid or alkali, then we heat under reflux. So there is a formation of acid, there is a conversion of alcohol into acid, and so on. The basic synthesis of the acid is done from alcohol. Or if I'm supposed to make vinegar, 2-carbon acid, then what to do? Again, we will have to start from 2-carbon alcohol. Acid is basically made from alcohol. 2-carbon acid needs 2-carbon alcohol, and this carbon must be alcoholic carbon. Second carbon, that is having the acidic group at the moment. Initially, it is having alcoholic group, OH group. So I'm going to write H. This is ethanol. It's called ethanol. And again, in the presence of K2Cr2O7, we can use K2Cr2O7 as well. In the presence of aqueous acid and heat under reflux. So it reacts with oxygen. Again, I'm going to write the atomic oxygen, one oxygen within the bracket, and there is a formation of ethanoic acid. This carbon will be under attack, under chemical change. It will lose 2 hydrogen. Any one of these 3 hydrogen, 2 hydrogen will be lost. They will change itself into H2O, water, and rest of the carbon is going to have 1 oxygen group over here. So loss of hydrogen, introduction or gain in oxygen is called oxidation. So this is called, these two methods, the processes are said to be oxidation of alcohol. So carboxylic acids are basically they are formed by the oxidation of alcohols, oxidation of ethanol, propanol, and so on. Basically, primary alcohols are changed into carboxylic acid, primary alcohol. So we can synthesize generally, but generally we are, if we are supposed to synthesize the carboxylic acid, then we will start from alcohol. Oxidation of alcohol gives carboxylic acid and water. When ethanol is formed from sugar, fructose, and glucose by fermentation process, then this alcohol is reacted with oxygen in the presence of bacteria. By the action of bacteria that is said to be acetobacter, the ethanol produced in the previous process react with atmospheric oxygen to make ethanoic acid, vinegar, and water. We can write this equation like that. Ethanol goes to ethanoic acid plus water. Basically, first of all, I'm going to write the first one equation. This one, glucose, C6H12O6. There is an aqueous glucose is basically fermented in the presence of yeast to make 2 mole of C2H5OH ethanol, and 2 mole of carbon dioxide is formed. So 1 mole of glucose is going to gives us 2 mole of ethanol and 2 mole of carbon dioxide. This ethanol formed, then it is again reacted with oxygen. So C2H5OH, it reacts with oxygen, atmospheric oxygen, in the presence of acetobacter. And this alcohol changes itself into ethanoic acid. Two carbon alcohol will change into two carbon acid, that is ethanoic acid. This one, ethanoic acid, plus H2O is formed. That is the second process to synthesize ethanoic acid or vinegar. That's all about today. Thank you very much. Please subscribe my channel, hit the bell icon, and share it with your friends. Thank you. Thank you very much. Have a nice day.